If you read it in the book, this is section 1.1. It says, you work in the marketing department of a soft drink company and are experimenting with a new soft drink can that is slightly narrower and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4, as shown in the picture. Okay. A, express the volume of the can as a function of R. B, express the volume of the can as a function of H. So the volume of a cylinder is this formula here. V equals pi r squared H. In this expression here, you would say that the volume is a function of the radius and the height, because it's got both R and H on the right-hand side. Right? What they're asking us to do here is try to write volume only as a function of R. Okay? Well, how are we supposed to get rid of the H? That's why they gave you this up here. If you know a constant ratio of the height to the radius, if you can solve that for H, you can substitute into this for H, and then it would only be in terms of R. How do you solve this one for H? What do you get? H equals 4R. Right? That's just taking this and solving for H. Now, substitute into our formula for H. Now we've got volume equals pi r squared, and then in place of the H, put 4R. And you could simplify that. That is 4 pi r to the third. So now our volume is a function of only one variable, R. 4 pi r squared times R. Okay, well, then how can we write this thing only in terms of H? Yeah, just solve this for R instead, right? So solve that for R, you would get R equals H over 4. Right? You would have to multiply both sides times R, divide both sides times 4. Okay, then what would you do with that? Put it in the place, in our formula, in the place of R, put H over 4. So volume equals pi times H over 4 squared times H. So volume equals pi over 16 H to the third. So I squared the H and I squared the 4. That's why I got a 16 in the denominator. So now volume is only a function of H. If you tell me the height, I tell you the volume.